you everybody for joining us today. To start us off, I have a question here. Um, as you saw by the title of today's presentation and STEM Wednesday, we're going to be talking about the upcoming solar eclipse happening in just a little over a week from now on April 8th. But I'd love to hear if any of you have experienced a total solar eclipse in your lifetime. I know there's been very few total solar eclipses, and we're joining from all around the country, so it might be some of us got luckier than others to see a total solar eclipse. But I'd love to hear your experience with that. A couple people, I saw partial eclipses. Partial eclipses are definitely still pretty cool to see, but they're not quite the same experience as a total eclipse. To have that sun completely blocked out is a pretty wild thing. And we have somebody that'll go unnamed that was old enough to see a solar eclipse when they were very young, a total solar eclipse. Well, we'll jump right into talking about solar eclipse and how you can use your Labdisc to measure some of the different effects of the solar eclipse with your students. So, my name is Jonathan Lockwood. I am a STEM training and development specialist with Boxlight. I do trainings on all of our STEM products. I've done quite a few of the previous STEM Wednesdays, so hopefully some of you are joining us again today. And we're going to be focusing today on using the Labdisc, like I said, to measure a solar eclipse. There's quite a bit that happens during a solar eclipse, and I maybe want to fill you in on a little bit of that before we talk about the Labdisc piece of this. So, if you're unfamiliar, a solar eclipse is when the moon passes between the Earth and Sun, and effectively the shadow of the moon is cast on Earth. We see this in varying degrees, more frequently than not, but the possibility and the occurrence of a total solar eclipse where the moon essentially blocks all of the sun's light is a very rare experience and something that we'll see on the 8th of April. So on April 8th, what we're going to see in the US and parts of Mexico and Canada is a total solar eclipse, which means that the sun is going to be completely obscured by the moon. And during this time, all we're going to be able to see is the corona layer of the sun. So if you studied the sun at all, the sun has multiple layers to it. The corona layer is a part of the sun that you typically can't see during the day or while you can see the rest of the sun because the light emanating from the sun blocks out your ability to see that corona. So there's a lot of actually cool scientific observation that takes place during this time, having that sun blocked out. So there'll be a lot of scientists with a lot of telescopes focused on the sun at that point in time as that eclipse is happening. Um, in a total solar eclipse, you're not going to see complete darkness. You're still going to see some light reflecting off the moon. And this is because the moon is not a perfect sphere and it's not able to perfectly block the sun. But there's going to be some reflection within the moon's craters and valleys on the moon that allow just a little bit of that light to escape. So during that total eclipse, it's going to look like just sort of the white corona of the sun with a big black dot right in the middle of it. If you've seen one of the eclipses that have happened more recently, I know somebody in the chat said that they saw a partial eclipse. You might see one of those other pictures down there at the bottom where you might have seen the sun sort of partially obscured or a chunk is almost missing from the sun, so to speak. I found this map on weather.gov, and this map just gives you an idea of how much of an eclipse you can expect to see if you're in the continental United States. So the path between the two red lines indicates the path of totality. So totality is going to be where the sun is essentially completely blocked out by the moon. You're unable to see the sun itself. You just see the corona layer of the sun. So if you're one of those lucky people that live in that narrow strip across the country, you're going to have by far the best experience. Um, so people in Texas, I know we have a lot of people. I saw somebody in the chat saying they're going to be in Texas, hoping to see that eclipse during that point in time. Outside of that band of red, you will still see the eclipse. but you're not going to see a total solar eclipse. You're going to see a partial eclipse. And the grid here sort of gives you an idea of how much of an eclipse you're going to see. For me, I'm in Orlando, Florida. I'm probably going to see about half of the sun being covered up by the moon. So I won't get as drastic of an effect as you might in other places. So when you will see it, it's going to be a different time for everybody depending on where you're at. The eclipse, while the maximum or the most coverage that you'll see will only last for about 4 minutes. So if you are outside of that path, time it lasts is going to be a little bit less. But for those of you who are in that path of total uh, eclipse or path of totality, you're going to see just a little over 4 minutes of total eclipse. If you want to figure out the exact time that the eclipse is happening near you, you can definitely do a quick Google search. There's all sorts of tools out there that can do it. This graphic also shows you um, a good representation of approximately what time you can expect the eclipse over your area if you know your location on the map. Now, this is a not perfect map of the United States, but if you do want to convert, that UT is universal time. So if you're in Eastern time, you subtract 5 hours from that. Central time, subtract 6. So everybody in that gray ring around the main dot, those are the people who are going to see some varying degree of eclipse. The people who are on that path following the black dot are going to see a complete total eclipse, which is going to be um, this is a really cool thing that's happening. For many of us, this is going to be something we might only have the opportunity to see once or twice in our lifetime. There was an eclipse back in 2017. There's an eclipse this year in 2024. The next time we'll experience an eclipse over the United States, a total eclipse, will not be until I believe it's 2044. So that's almost 20. Oh, it is 20 years from now. So this is a really cool experience to show your students and get out of the classroom, just experience it. I know tons of businesses and organizations are having all sorts of cool eclipse viewing parties all over the country. So during the eclipse, there's some things that you can expect to see. Obviously, the biggest is going to be the dimming of the skylight. So depending on how uh, or where you're located, you're going to see varying degrees of dimming of that skylight. Secondly, you'll start to feel a cooling of the ambient temperature. So the sun provides most of the heat towards the earth. Without the sun there, you'll notice that temperature cool. You'll notice in the atmosphere, if there is clouds in the atmosphere, you'll notice that there's going to be a diminishing of any low level clouds. And you may also notice if it's windy prior to the eclipse, you may notice that there's a reduction in wind as well. So the heating of the earth by the sun is what causes some of the uh, wind activity on earth. And all of these things definitely sound like great things that we could study with our students and try to find relationships between things like uh, light levels and temperature. And that's where the Labdisc is a great tool for us to use to do that. So to help you out, and I'll mention these to start, we have 4 different lessons available on My STEM Kits where you can actually use them prior to the eclipse and during the eclipse with your students, or even after the eclipse, some of them. So there's 3 lessons in the Eclipse Shadow Kit that build on top of each other, one after the other, and those are really meant for 4th to 8th grade. But if you're teaching high school, they're just as applicable for students who don't know about the eclipse. They introduce what an eclipse is, give you an idea of how that path of totality is formed. And even one of those lessons is a design challenge that allows students to create a pinhole viewer so they can view the sun without damaging their eyes by creating a projection of the eclipse on the ground. And then there's a lesson specifically designed for using the Labdisc to analyze the eclipse. And that's what we're going to mention today. So using the Labdisc to study the eclipse, what we really are going to want to look at is the relationship between temperature and light level. So there's a lot of different questions we can ask students, and if you view those lesson plans, you'll see a ton of those questions we can ask. But the first is, uh, do we expect to see a relationship? So as the temperature or as the light from the sun decreases, do we expect the temperature to follow that? A good follow-up question to that to get students to think about is, does that uh, relationship happen uh, at the same time? So as soon as we see the light go away, do we notice that it cools immediately? Or is there a delay in the cooling and the light level? So on the Physio, Gensci, and Enviro Labdisc, all of those have the sensors needed to measure both light level and temperature. So you can use any of those three lab discs to measure this. So how I would do this is I would take my lab disk and I'm going to set up my lab disk to measure both ambient temperature and light intensity. On the lab disk, you can set up a sampling rate of 1 sample per second. And I would set it to a maximum number of samples, which is going to be 10,000 samples. The reason for this is the Eclipse lasts, like I said, a little bit over 4 minutes. So having that lab disk start a little bit before the eclipse and letting it run all the way through the eclipse, maybe even a couple minutes after the eclipse ends, allows us to view the data in completion. Um, when you're measuring the light intensity with the lab disk, there's a couple important things to note. The first is if you have your lab disk, and I don't know if you can see my camera, on your lab disk, you want to make sure that the colored plastic piece is rotated to expose that sunlight sensor or that light sensor, as well as the temperature sensor. And those sensors are located directly below the button that corresponds to them. Um, this is not an experiment where you get a second chance at it. So having as many lab discs as you have in your school set up and measuring at the same time is going to be most useful and most effective, even if they're gathering the exact same data. Because if one of them, for some reason, doesn't capture the data you want, you can't just reverse the sun and the moon and have them move back to their original position and start it over again. You have to wait another 20 years for that to happen. So definitely something you want to make sure you have as many lab discs as you can measuring. The second thing is when you are measuring light intensity with the lab disc, and this is really important for measuring the intensity of the sun. If you point the light sensor on the lab disc, on any of the lab discs, directly towards the sun, it will actually overwhelm the lab disc and you're going to get an inaccurate reading because the light generated by the sun is beyond the maximum measurement for the sensor itself. So to help get a consistent reading and prevent that data from actually overwhelming the lab disk, what you want to do is lay just a sheet of white printer paper flat on a table or flat on the floor and place the lab disk on its back directly on top of it. If you view the lab disk solar eclipse lesson on my STEM kits, you can actually see a picture of what that looks like. But just lay that flat paper down um, right on a flat surface and put the lab disk right on top of it. You don't want that sensor pointed directly at the sun. And as Hannah mentioned in the chat, they tried to measure the sun with the lab disk during the partial eclipse, which was, I think, just last October, I believe, 2023. And it oversaturated the sensor because they had it directly pointed at the sun. So keeping that sensor indirectly uh, receiving sun is going to be your best bet for an effective reading. And like I said, this is not something you can start over again if you miss it. So you want to start recording that data ahead of time. If you have the lab disk set to 1 sample per second and 10,000 samples, you can start it 10, 15 minutes early if you're worried about missing it, and it will have enough samples to run all the way through the experiment without stopping midway through. So once you have that data collected, depending on which grade levels you're working with, you can have varying levels of conversations with the students. If you're working in maybe a K through 5 classroom, you can just display that data on your display in your classroom and maybe show them the graph or show them some different temperature and light level measurements and see if they can find a relationship between them. So do they notice that when temperature increases or temperature decreases, that the light is following that same pattern? You can also talk about, is there a delay in uh, temperature and light? Do they start to change at the exact same time? So that might be something a little bit more complicated. So you can maybe discuss that with your middle school students, um, and think about, does the graph actually line up? And then finally, you can talk about what would happen if the sun were to permanently disappear. This is maybe something that would be a really good project or a question to work on for high school students. You could give them some different scenarios. So they collected the data on the lab disk and they have a rate at which the temperature starts to decrease. You can have those students try to predict about how long in time it would take for the temperature on Earth to maybe reach freezing. So if the sun were to disappear and the light, sorry, if the sun were to disappear or be completely blocked and we receive no light on Earth, and that temperature started decreasing, we can see how long maybe it takes for the planet to start to freeze over because that sun is missing. So hopefully that never happens, but it's a good way for students to take and learn how to relate relationships in data, and sort of extrapolate those out to later times using a given rate. That's all I have for the lab disk in the solar eclipse. Unfortunately, I was not able to demonstrate a solar eclipse for you today. But if you stay tuned next week, or sorry, the week after, actually, on April 8th, you'll have the opportunity to view one yourself. Um, so I encourage everybody to get out of the classroom on that day and actually experience a solar eclipse. But I will warn you that staring directly at the sun is damaging to your eyes and not to do it. There's tons of businesses that are handing out free solar eclipse glasses to prevent you from damaging your eyes when looking at the eclipse. There's also a pinhole camera lesson plan on my STEM kits that allows you to view the eclipse indirectly and prevent damage to your eyes. Um, if you are into gardening, or maybe you have a garden at your school, next week, Jillian is going to be joining us and talking about how you can use that garden or how you can create STEM focused lessons for gardening with your students. So I encourage you to join us then. And I will stick around here for a couple minutes if anybody has any questions or wants to share anything in the chat. But I hope that once you have those lab discs running during that solar eclipse, that you see some really cool stuff and you have sort of a once in a lifetime experience with your students in just over a week. So thank you for attending today, and I hope to see you in future weeks.
Thanks, Jonathan. I just wanted to pop in again for anyone who joined later, didn't catch it the first time. All the lessons and everything Jonathan was talking about here with this lesson is in my STEM kits. The easiest way to find it is to go to Browse Lessons, and at the top you'll find the newest lessons where all of our Eclipse lessons are. This one, the Studying the Solar Eclipse, goes over everything Jonathan just did, has pictures, student handouts, guiding questions, all sorts of great things. So even if you don't have a My STEM Kids account, you can sign up for a free trial and get the lesson there. Thanks, Jonathan. This was great. I'm excited to try it out again.
I'm jealous that you'll actually be in a place with total eclipse.
Hopefully, we're also calling for like rain and thunderstorms, so we'll see.
Thank you, everybody, for joining us, and hope to see you next week.